Hello, Namaste. Today I am going to show you a video about the lesson force. Force, the first unit of the compulsory science for grade 10. We have four problems. Before solving these problems, first of all, we discuss between the relation between the acceleration due to gravity and the radius of Earth. Okay. Relation between acceleration due to gravity denoted by g and radius of Earth r. So we know that g is equal to gm by r square, where g is gravitational constant and m is mass of Earth and r is radius of Earth and g is acceleration due to gravity. And the gravitational constant is a constant quantity and mass of the Earth is also the constant, but the radius of Earth is not a constant. It is different for different places. Our Earth is not perfectly spherical. It is bulging at the equator, and similarly there is a highland, high mountains, plain areas. For example, suppose this is a mountains and this is a plain area. So this is the sea level. Then look at here. If it is the center of the Earth, then look at this R and R. So this is S1 and this is S2. Say this height. Okay. And so the radius at this point and at this point is different. Okay, they are not same. So R is variable. So what we can write from this result, since G and M are constant, so G varies 1 by R square. That means G is inversely proportional to the square of the radius. So acceleration due to gravity is inversely proportional to the square of radius of the Earth. Okay, and it means the radius of Earth determine the value of g. So when r is increases, then g decreases, or when r decreases, then g increases. That means when the value of r is more, the value of g is less, and when the value of r is less, the value of g is more. So the relation between g and r, have some importance rule, to find the weight of the objects. So the weight of the object is different for different places, and the value of g also differ by place to place. We have one question here. The value of g is more at top of more at bottom of mountain than that at top of the mountain. Why? Okay. So for this, let us draw the same diagram like before. It is Earth center, and this is the bottom, and this is the top. So look at here, the R at bottom and R at top of the mountain. This R is greater than this R. So the radius is more at top of the mountain and less at the bottom of the mountain. As you know that G varies 1 by R square. That means G is inversely proportional to the radius, square of the radius. So more radius, less acceleration due to gravity. Less radius, more. So comparing these two radius, the radius is less at bottom and more at top. So to write the reason for these questions, radius at bottom is less than that at top of the mountain. Okay, and G is inversely proportional to the square of the radius. So hence, the value of G is more at bottom than that at top of the mountain. Okay, so more R, less G, less R, more G. So in other words, the value of G is less at top than at the bottom. Okay, so similarly, the value of G is more at polar region of the earth and than that in the equatorial regions, because in polar region the radius is less and the value is more. Okay, and now we solve the following problem. So find the acceleration due to gravity of the freely falling body when it is at a height of 100 km from the surface of the earth or the mass of earth. Listen, it is earth and the mountain, not mountain, at the height, you can give that. Object is here and it is 100 km and it is the radius R. It is given us 6400 km and this is height, it is height. So we have to find the acceleration due to gravity. We have to find G is equal to what? Okay, to find that, here first of all we write the given informations. So mass of the earth is given, that is 6 into 10 to the power 24 kg, and we are given radius also, that is 6400 km. We have to change it to the meter. We change it by multiplying kilometer by 1000, so 6400,000 meter, and then height at which the object is situated is 100 km, and this also should be changed into the meter. So we multiply this quantity by 1000, so 100,000 meters. Okay, and these are the given informations. One more information that we need to write is that gravitational constant, that is G. The value of G is 6.67 into minus 11 Newton meter square per kg square. Now we have to find the acceleration due to gravity. Acceleration due to gravity at height h. Okay, and this is denoted by gh, okay, or g1 is equal to what? Okay, sorry, height, it is height, gh is equal to what? Now we know the formula. G is equal to gm by r plus h whole square, and the height is given, so we write here gh. Okay, acceleration due to gravity gh, acceleration due to gravity at the height h is equal to g times m whole divided by r plus h whole square. Now we put the values. So the value of g is 6.67 into 10 to the power minus 11 into m is 6 into 10 to the power 24 kg. We don't need to write the unit while calculating. And r is 64,100,000 plus, and the height is 100,000 whole square. So you can use calculator. So by using calculator, you input all these values in the calculator, then it will give you the value. Or you can do just manually. 6 into 6.7, that is 40.02, and 10 to the power minus 11 times 10 to the power 24, that becomes 10 to the power 13, and here we have 65,100,000 whole square. Okay, we add first. Now it is easy to calculate this quantity by using calculator. Okay, now using calculator you will get the value 9.47. Okay, and other also 2 1 also we will get, and this is the final value, and the unit of acceleration due to gravity is 9.47 meter per second square. Okay, this completes the first solutions. Now we solve the another problem. Okay, so in the another problem, what we have, calculate the height above the earth's surface at which the value of g is 4.9 meters squares, meter per second square. Okay, suppose this is the earth, and you have to find this height equal to what, where the acceleration due to gravity is 4.9 meter per second square, and the radius of the earth is given. How much is that? 6.4 into 10 to the power 6 meter. Okay, you have to find this height. The acceleration due to gravity is given, and further m and r is also given to us. M, r is there, m is also given. We can write the value of g, gravitational constant. Okay, solution of 2. Here first of all we write the given informations. Now GH is equal to 4.9 meter per second square, and radius is 6.4 into 10 to the power 6 meter, and the mass is 6 into 10 to the power 24 kg, and the value of gravitational constant is 6.67 into 10 to the power minus 11 into 10 to the power, unit is Newton meter square per kg square, and we have to find the h. Okay, h is equal to what? The height. Okay, from the surface. This is a surface of earth. surface of Earth. The height from the surface of Earth, h is equal to what? And this part is r. So now we have a formula. We know that gh is equal to gm by r plus h whole square. Okay, so this equals 6.67 into 10 to the power minus 11 into mass 6 into 10 to the power 24, and the value of r is 6.4 into 10 to the power 6 plus h whole square. Okay, now we have to find the value of h. Okay, so now we have these relations by cross multiplication this quantity. Okay, now g of h is equal to 6.67 into 10 to the power minus 11 into 6 into 10 to the power 24 by 6.4 into 10 to the power 6 can be rewrite as 64,123,64,100,000 plus h whole square. Okay, so since we have given gh, acceleration due to gravity is given, so we now use this. Look at them. By cross multiplication, gh is 4.9, and this quantity when multiplied 40.02 into 10 to the power 13 divided by 64,100,000 plus h whole square, or by cross multiplication 64,100,000 plus h whole square equal to 40.02 into 10 to the power 13 by 4.9. So we have to find the value of h. So we take square root on both sides. Taking square root on both sides, root on both sides, we get, so square root, the square quantity under square root gives that quantity without square, 64,100,000 plus h equal to, we have this result 40.02 into 10 to the power 13 divided by 4.9. Okay, so look at here now. So on calculating this by using calculator, you will get the value 903733 7.52. Okay, so finally we have got look at here. So from here to this place, I've got that 64,100,000 plus h equals 903733 So the value of h is 903733 minus 64,100,000. We get 2637,337.52 meter. Okay, at first, and then to convert it in kilometer, then we divide by 1000, so it gives 37.34 kilometer, which is the required height, at which the value of g is 4.9 meter per second square. Okay, so this is the half. The acceleration due to gravity becomes half at the height of 2637.34 kilometer from the surface of the earth. Okay, and this is the solution of 2. Now we have another problem to be solved, that is question number 3. Look at that question 3. In the adjoining figure, the gravitational force between x and y is 3.335 times 10 to the power minus Newton, and the mass of y is 200 kg. Then find the mass of the body x. Okay, so the solution of 3 here, we are given that the mass. Okay, let the mass of x, let mass of x be m1, and this equals the m1, and therefore you can write m1 is equal to m1 we have to find what, and mass of y, mass of body y, that is m2 is given. How much is that? 200 kg, and the distance between the two bodies, distance between the centers, distance between the center of body x and y, that is d. Look at here, they are connected, and the radius of x is 5, so you write 5 plus, but the radius of diameter is half of 30, because 30 is a diameter. Okay, sorry, radius of this body y is half of 30, that is 30 by 2, and the sum of these two radius, is the distance between the two centers, that is 20 meter. Since d equal to, when the two spherical body are connected at a tossed at a point, then distance is r1 plus r2. So distance is 20 meter, and also we have given that force of gravitation is 3.335 into 10 to the power minus 9 Newton, and also we know the value of z is 6.67 into 10 to the power minus 11 Newton meter square per kg square. Okay, so this is the information given to us, where we have to find the mass of x. So to find that, we have now the relations. Okay, so now we know that, we start here. That f equal to g times m1 m2 by d square. So starting from here, the value of we have to find the value of m2, m1, value of m1. So first of all we cross multiply, g m1 m2 equal to f d square, or the value of m1 is f d square by g times m2. Now we put the values of f, d, g, m. The value of f is 3.335 into 10 to the power minus 9. Value of d is 20 whole square, whole divided by value of g is 6.67 into 10 to the power minus 11 into the value of m2 is 200. So using calculator, okay, you can find the value of this value of s of the mass 1 is 100 kg using calculator. Okay, so square of 20 times 3.335 into 10 to the power minus 9 whole divided by 6.67 into 10 to the power minus 11 to 200 is this. What we have done here is using calculator. Okay, and therefore the value of m1 is, hence the mass of x is 100 kg, or it depends on the decimal place that you have taken during the calculation, and it may be just approximate around 100 kg. Okay, now we have a final problem, and that problem is, look at there, you read that problem. A man can lift 50 kg mass on the surface of earth. How much mass can he lift on the surface of moon? Okay, so let us see that. Question number 4. Here, the person lifts the object once at earth and once at moon. So at earth, the mass m is 50 kg, and the acceleration due to gravity GE is 9.8 meter per second square. Okay, and let us suppose this is m1. Okay, and at moon we have to find how much mass does it lift up. Okay, so G moon is 1.67 meter per second square. So the force applied by the person or man is same both at earth and moon. So now we have a relation. In that case, force is same. So we can write that m1 into GE equal to m2 into, right, cross into gm. So the value of m1 is 50, the value of g is 9.8, and value of m2 to be determined, and the value of gm is 1.67. Okay, so from that you can find m2 by calculating this into 9.8 divided by 1.67. Okay, by using calculator you can find the result. Okay, we'll do it in calculator. The value is 293.41. Okay, it is a kg. So hence the man can lift up 293.41 kg on the moon. This is the answer. Okay. Thank you for watching this video. We'll see more videos in coming days. Thank you.